Okay, today we're going to start learning about Newton's method. What Newton's method does is that it uses tangent lines to approximate the graph of the function near its x-intercepts. If you look at page 229 of your textbook at figure 3.6, as well as page 230, example 1, those are some good examples of what Newton's method looks like. I will do my best to explain to you Newton's method through this picture. What Newton's method says that I should be able to approximate this zero through the use of tangent lines. So what I'm going to do is just pick some value on this graph. Somewhere close to the C value is what we're always going to do, and I'm calling it C value because there's going to be a lot of x's, and really what I'm doing is I'm trying to figure out where it crosses the x-axis here. So I just went ahead and labeled this first point as x sub 1. So it would be x sub 1 comma y sub 1, and I went ahead and said that's the function, or f of x sub 1. So what I'm going to do is I'm going to draw a tangent line to the curve here as best I can. And what I'm going to do is I'm going to write the equation of that tangent line to the curve. The equation of that tangent line to the curve in point slope form would be y minus f of x sub 1, that's the y value, and that we write equals m. Well, the slope would be f prime of x sub 1, and then x minus the x value, which would be x sub 1. What that allows me to do is I'm going to be able to approximate a new value of x, and we'll call this x sub 2. Well, in order to find this x sub 2 value, that's really where the y is equal to 0. So what I would do is I would substitute 0 in for y, and I would solve this equation for this x value, which would be my x sub 2 in this problem down here. So this falls out. What I would do to both sides probably is just divide by f prime of x sub 1. So I'll divide both sides by f prime of x sub 1. That gives me negative f of x sub 1 over f prime of x sub 1. And this equals x minus x sub 1. What I would do now, I don't really need these parentheses, so I'm going to get rid of those, is I want to solve for this x value. So I would add x sub 1 to both sides. And when I did that, I'd end up with x sub 1 minus f of x sub 1 all over f of f prime x sub 1. And this equals that new x value, which I have called x sub 2. Now, what does that do? Well, what it does is give me a new starting point, and then I'd have to draw another tangent line to the curve. And notice what happens this time is that my new x value has now gotten closer and closer to C. So basically what we're doing is going back and forth between two values, okay, to come up with this C, this x-intercept. So it's just a way of finding x-intercepts without knowing a lot of information, or if it's an x-intercept that's hard to solve for. We're going to fill out a table to do that, but I wanted to give you kind of an idea of where this was coming about rather than just doing this process. It is a process, but hopefully this helps explain the process to you. After you would do this, you would just keep redoing this, and you draw another tangent line to the curve every time you get closer and closer to the C value. Okay, what we're going to be doing in this first example is we're going to complete 2 iterations of the Newton's method. They do give me my initial guess. My initial guess, they tell me, is x of 1 will be 1. Normally we'll have to find our initial guess through a graph, but anytime they give me my initial guess, I will be using that. So we're going to always just complete these charts. and you'll always be given the chart. So all you've got to do is fill it in. This says find x sub n, which would be x sub 1. Well, we know that's to be 1. Then it says to find f of x sub n, which would be f of x sub 1. That means I'm going to plug 1 in for this function right here. So I would end up getting 1 squared, which is 1 times 2 of 2. 2 minus 3 is negative 1. Now it says find f prime. Well, I first need my derivative, so that's 4x. Find f prime of x sub 1. So that means I'm going to plug 1 in for my derivative, which gives me 4. Now it says divide those two values. So I get a negative 1/4. And the last thing it tells me to do is to take my x sub n minus this. So take this and subtract the two values. So I end up getting 1 minus negative 1/4, which would be 5/4 or 1.25. This becomes my new x value, and I carry it down below. Let's refer back to the example that I gave you, or the explanation of Newton's method. When I first started out, I gave an initial guess of 1, and then I would draw a tangent line to the curve using the equation of a line. I would then be able to figure out what this x value is, and I called it x sub 2. The x value that you get for x sub 2 is found by doing x sub 1 minus the function value divided by the derivative. Notice that's what the last part is. So x sub 2 is found by taking that x sub 1 minus the function value divided by the derivative. So hopefully this chart makes more sense because of the explanation I gave you through that picture. So let's go ahead and finish our second iteration. This value, what it means is it's closer to that x-intercept, and by doing and finishing this one, we will be even closer to that x-intercept. So we're going to take 1.25 now and plug it in for our f of x, because we're supposed to figure out what f of x sub 2 is now. So I'll take my function value 2 times 1.25, and I will square it. So let's try that again. 2 times 1.25 squared, and then I subtract 3. This gives me the answer of 0.125, and I will put that on my chart now. 0.125. F prime of x sub 2, you're going to plug 1.25 in for your x. So we'll go over here and write 4 times 1.25, and that gives me the answer of 5. So I'll write 5 here. Now I'm going to divide those two values. So I'll come back here, 0.125, 0.125 divided by 5 gives me the answer of 0.025. So I'll write 0.025 here. And the last thing I do is I subtract 1, my initial value over here, minus 0.025. So 1.25 minus 0.0 problems. You're going to want to have your calculator available. What I'm going to do is I am going to spend a lot of time talking about iterations, and we're going to do as many iterations as we need to get to 0.001 from, or the difference between two x's to be less than 0.001. So our first initial guess they give me is 0.5. So I know I'm going to need my first derivative, so I'll go ahead and squeeze that in here. The first derivative is plus 1. I'm going to plug 0.5 into my function value. So I'll take 0.5. So I have 0.5 to the 5th power. I have then plus 5 minus 1. Hit enter. That gives me the value of, not the correct value. What did I lose here? Oh, I didn't type it in right. So I need to put a 0.5 here. Sorry about this. Okay, now I have the right value. What I'm going to do is I'm going to hit store, and I'm going to store this as A, because otherwise I'm going to end up typing in decimals constantly. So back over here, I'm going to go ahead and put in, I got 0.46, and I'll go ahead and round it 88. Then I'm going to find F prime. So I'm going to plug in. I'm at 5.5 to the 4th power. I will apologize, this probably will take me a while to do a video on this just because of the length it's taking me to type things in the calculator. So if I hit enter on this, I get the value of 1.3125, and I'm going to store this as B. So I'll hit store, and I'll put B. And it didn't hear store. So store, and I'll store that as B, and hit enter. What I've done right now is I have this as my A and my B. So now I'm going to be dividing those two things, so I can just type in over here A divided by B rather than retyping those all in. You can do that also on your calculators. So look for the store button. On the 86s, it's above the on. So I'm going to round this just to 4 decimal places. So I get negative 0.3571. Again, I'm going to store this. This time I'm going to store that as letter C. So store as C. It does convert it to a fraction for me. That's fine. Your calculator may leave it as a decimal. That's fine as well. So what I'm going to do now is I'm going to take my x value 0.5 minus my C. And that gives me the value of 0.8571. I am going to store this as D. So store this as D. And I'll bring that decimal down here. And this is ready to start my second iteration. So when I go and I'm going to plug this back in for my function value. So I'm going to just say it's, remember it's D. So I'm going to say it's D to the 5th power plus B minus 1. That gives me the decimal 0.3198. And I will store that as E. So then I'm going to go ahead and put in my D again for my F prime. So I'm going to come over here. 5D to the 4th power. And then it says that the derivative is plus 1. That gives me 3.699, and I'm going to store this as F. And I'm going to run out of time here, so I'll pick this back up on the next video. Okay, I need to go back here and make a little correction here. I name this as G. That's my output value, so that way I could then divide G divided by F. This calculator doesn't let you store them as E because E is a value. So that's one of the reasons it wasn't reading it correctly. So now when I divide G divided by F, I get my which would be these two values, divide those, I end up with 0.0865. Then I'm going to take this x value, which I had stored as d. This was d, and I'm going to subtract d minus, well, I'll store this as h. So I'll store as h, and now I can do d minus h. So I'll come over here, d minus h gives me 0.7707. There's my new x value, 7707. I'll store that as j. Store it as j. And I continue on in this pattern. What I'm going to do is, I'm not going to finish this. I'm just going to write in what you should be getting when you put these values in, because it will take too long on the video to continue. So if you have trouble getting these values, make sure and ask me. You should be approximately around these amounts. It just depends on how much we're rounding. But I will fill in this chart. What you keep getting are long decimals, and I am rounding these. Okay, after the third iteration, you have 0.7553. That's not close enough. They want me to be within 0.001, so I'm getting closer. So when I start plugging these values in, I have these numbers. And I know I'm getting really close because these decimals have gotten really small. So I end up with 0.7549. Notice that these two right here differ between 0.001, so I can now stop. So my approximation for my x-intercept is 0.7549, or you could say 0.755.